This is a West 9 News special report. Reporting live now from the West 9 studios is Marina Kurioka.
Good evening, I'm Marina Kurioka from West 9 News. Tonight we have a special report on the missing ocean where Plano West Senior High now stands. For more information, we go to our reporters Emma, Reilly, and Whitney Patterson.
Thanks, Marina. I'm Whitney Patterson. And I'm Emma Reilly, and me and Whitney stand here in the sedimentary rock, the only remnants of the ocean that used to exist now on the current grounds of Plano West Senior High School.
As the fossils on these rocks represent, the shell here, as well as the shell implant on the ground, indicate the presence of life here millions of years ago.
We also found a more unique fossil that could possibly be, as our analysts tell us, remnants of an early crustacean.
For more on the life here that was formed millions of years ago, we'll go to our research analyst back in the studio, Stephen Ding.
Thanks, Emma and Whitney. As you look at our first fossil, it looks what appears to be a shell inside the rock, a shell fossil inside the rock. Well, many ask, why is there a shell fossil so many miles inland? Well, the reason why is because 100 millions of years ago, there was an ocean that was located where Texas and New Mexico are now. So that's why there are shell fossils and other aquatic fossils found where we are now so many miles inland. As we look at our second fossil, we just see a massive, what looks like to be a shell-like creature. You can see the ridges inside the rock and how these fossils were left from millions of years ago of aquatic creatures that lived in what we now know as Texas. And in the third picture, if you look at the finger where that's pointing, you can see that makes the imprint of what looks like a small crustacean, a shrimp-like creature. So we see that as further evidence that back hundreds of millions of years ago that we did have an ocean here, and that it's evident in the fossils we can find. Now, based on research analysts, we can say that these fossils are around 85 million to 100 million years old. And we know that because of a theory called relative dating. And through relative dating, we compare it to other fossils that were found, and then we can apply that to say how old the fossils we find are now based on the fossils that have been found before. Back to you guys out in the field.
Thank you for that insightful report, Stephen.
Live from the creek behind Plano West, this has been Whitney Patterson
And Emma Reilly.
Back to you, Stephen.
Thanks, Whitney and Emma. So today we're going to talk about a really interesting concept called Continental Drift. And the forecast from the past couple years tells us what's going to be happening in the next 50 million to 100 million years based on what's happened in the past. To show you this, let's head to our computer and I'll show you what's going on with the Continental Drift in the next couple years.
Alright, as we log onto the computer, it's important to first understand the geologic tectonic activity around us. Now, if you look where we live here in North Texas, there really isn't much as far as tectonic activity. We're not near any hotspots, nor are we near any of these moving plate boundaries. So in that case, how did this ocean just disappear from where we are? How did that ocean move away, per se? Well, that can be explained through the theory of continental drift. And this theory was derived by a man named Alfred Wegener. And he theorized that hundreds of millions of years ago, that there used to be a supercontinent called Pangaea. And as time went on and as plates moved in the lithosphere, these land masses began to move apart into two separate supercontinents called Eurasia and Gondwana. And the plates continued to move into the continents that we have today. And if you look at the future predictions that we have, the continents will continue to move, and the Atlantic Ocean is theorized to become much wider while the Pacific Ocean will shrink. And that's what's predicted for the next 50, 100 million years ago by many of the scientists today. Now, the sedimentary rock you saw down in the fossil site is sedimentary rock, and that's the rock you'll see with all fossils. Most fossil rocks will be sedimentary rock, and that can be seen through, that was formed through the igneous rock and the weathering erosion at that igneous rock and its sediments, and then through another hundreds of thousands, millions of years of compactation and sedimentation turns it into sedimentary rock. Alright, so let's log out of the computer here and we'll get you back outside.
I hope you understand now how continental drift works and how we use the past to forecast the future. Now back to Marina.
That concludes our special report. Good night and go Wolfpack!